Okay, so I can't get the dot cam to work, so this is gonna be a little bit of a rough YouTube video, but y'all can handle it because I'm gonna do 2 example problems for this. So today you need to learn how to do exponentials with percents. And we talked a little bit about percentages on block day, so real quick, you could pause the video after and do some warm up with this. Changing percents to decimals. Remember, to change a percent to a decimal, you're going to divide by 100. What this does is it moves the decimal to the left 2, right? So if I have 24, that's actually 24.0. So if I move this 2 to the left, I have 0.24. For all of the things today, you'll have to convert to decimals. So you can pause, do these real quick as a warm up, and come back to this. I'm not gonna pause, I'm just gonna move on, okay? So recall that a times b to the t, where a is the initial condition and b is the growth or decay rate. That's the equation we've been working with, right? Today we're gonna work with percentage. So it says the percentage can be expressed with f of t, just meaning y, equals a times 1 plus the rate, right? So this means, we've talked about it before, if I have 100% of my money and 15 additional percent of my money, I'm gonna have 115% of my money, right? Or if I had 100% of my money and I lost 10% of my money, I'm gonna have 1 minus that 10%, so I'm only gonna have 90%. So it's gonna definitely play into the growth and decay. A is still the same, A is our initial amount. R is going to be whatever our percentage of growth or decay is, and T is still going to be the time elapsed or number of cycles, whatever we're measuring. The 1 represents 100% as a decimal, right? So if we think 1 is 1.00, multiply it by 100, move it 2 to the right, that's that 100% plus our actual rate. We did something kind of like this with our P times e to the RT on block day. So it says if the rate is an increase, also known as growth, then it'll be 1 plus R, and it's going to be greater than 1, meaning if I have 100% plus 25%, I'm obviously going to have 125%. If I was here, I would have 125% of my money. If I wanted to convert that, I move 2 to the right, so that's how I'm getting that 1.25. If the rate is a decrease or decay, then the quality 1 plus R will be less than 1, meaning I'm going to have, if I had 100% of my money and I lost 25%, that's how I got to 75%. So if you were to convert this back, it'd say, oh, I had 75% of my money. Pause and listen to that again, if the breakdown of the A times 1 plus R to the T, right? Because this is originally our B, our growth rate, but our growth rate here is going to change a little because we're going to have 1 plus whatever our additional rate is. So I'm going to do 3 examples. So the first one says, write an exponential equation that models a population of 10,000 increasing by 3% per year. So I'm still going to go through and I'm going to circle 10,000. Sorry, it's shaking a little. And circle 3%, right? So I know I'm going to have an initial rate, right? So f of t, my initial, that models a population of 10,000, that's our initial amount, times whatever, 1 plus my rate. But I can't have my rate as 3 because that would just be 4, so I have to convert this 3% into a decimal, so I'll move it 2 to the left, so I'll get 0.03. So 1 plus 0.03 to the t. If I simplify that, it's going to equal 10,000 times 1.03. All I did was add that to the t. Hopefully you guys can see that. Let me zoom in a little. It says, at this rate, find the population after 4 years, right? So I have to understand that the f of t is my population. Then I have to also understand that the t is the years past in this case, right? Really important that we understand the input and the output for this. So if that is the rate, we're gonna find the population after 4 years. So I can plug this in, right? T is gonna equal 4. So I'll rewrite this equation real quick. So we'll have f of t, or total population, but t is, okay, let's just rewrite it. 10,000 times 1.03 to the t. I know that I'm plugging in 4 for t. After 4 years, what is my population going to be? 1.03 to the 4th. I need to put this into the calculator. Let's see how well you guys can see this. So it's 10,000, let me clear. 10,000, no, it's still not clear. What? I need to grab a different calculator. BRB. Okay. Ooh. You guys can get a calculator tomorrow or use your phone. But if you take a calculator out, make sure that you're putting it back at the end of the period. So it's 10,000 times 1.03 to the 4th power gives me 11,255 people. The answer says about, because we have a little bit more, but I'm fine with you just writing about 11,255 people after 4 years. Okay. I'll do this one. Okay. So write an exponential equation that would model a population of 500 decreasing by 25% per year, which means we're going to have exponential decay. So I'm going to start by writing y equals a, that's my 500, times 1. And if we think about decreasing, right, is that a positive or a negative number? Right, if we're decreasing, we have a negative number. It's like plus negative 0.25 to the t. What that means, I took that 25% and I converted it by moving the decimal 2 to the left to get 0.25. What that in turn is going to do is decrease this, right? I had 100%, but it decreased by 25%, so it makes sense that I'm going to get 0.75 here. So y is going to equal 500 times 0.75 to the t. It says find the population after 3 years, and this is the same as the other problem. T is going to represent our 3 years. So we're going to say y equals 500 times 0.75 to the 3rd power. Type this in. 500 times 0.75 to the 3rd power. Oh, I didn't put 0.75. 75 to the 3rd power, right? 210.9, that's about 211 people if you round up. 211 people after 3 years. So what I would suggest right now is that you actually pause and go ahead and try this one by yourself. And then afterwards, actually, maybe we'll do one more and then you try this one. I'll do the solution to all 4 of these. So let's do one more because this actually has one where we have to solve the exponential. Write an exponential equation that models a stock investment of $300 increasing by 200%. Right? If I convert 200% into a decimal, I'm going to move that decimal to the left too, so I know that my R, my rate, is going to equal 2 here. So y is going to equal 300 times 1 plus 2. And this is different because on all the other ones we had a decimal to the t. So you know that's going to convert to 300 times 3 to the t, meaning if I have my money and I'm adding 200%, then I actually triple. So at this rate, find the investment after 5 years. So that's going to be our t. So I'm going to say y equals 300 times 3 to the 5th. You can plug that in. So 300 times 3 to the 5th power gets us $72,900. And you can confirm down there, has the answer. So $72,900 is what your investment will be after 5 years. How long will it take for the investment to reach $9,000? This means you actually know the output instead. So we're going to substitute and say 9,000 equals 300 times 3 to the t. And you're just going to follow the same steps that you use for solving exponentials. So I'm going to try to isolate first. So I'm going to divide by 300 on both sides. 9,000 divided by 300 should be pretty easy. So these are gone. What's 90 divided by 3? Well, that's just 30 equals 3 to the t. I can't base change here, so I'm going to take the log of both sides. And when I take the log of this one, it's going to bring that t down. So you have the log of 30 equals t log of 3. Y'all killing me with this door. It's so squeaky. Okay, divide by log of 3. You guys can stay, just, I'm almost done. So type that into the calculator. So log of 30, make sure you close the parenthesis, divided by log of 3 is gonna get you 3.0959, which just means it's asking us how long is it gonna take to reach 9,000. That it's going to take we can say just 3.1 years. Okay, now this is where you should pause, try this next one by yourself, and then once you're done, watch the video of me doing it. So pause, try by yourself. Okay, so hopefully this is after you pause and tried this on your own, because watching me do them isn't going to help you learn how to do them. Okay, write an exponential equation that models a bank account balance decreasing. So I know I'm going to have negative 20%, right, or negative 0.2. My rate is negative 0.2 per year with initial deposit, aka this is my A, of $1,500. So y equals 1,500 times 1 plus negative 0.2 to the t. So when I'm doing that, I get y equals 1,500 times, if I subtract this, this is going to be 0.8 to the t. So all I did was subtract this. You can do it in a calculator or mentally. It says at this rate, find the account balance after 2 years. 2 years is going to represent t. So I'm going to say y equals 1,500 times 0.8 squared. And this number should be smaller than 1,500 because your exponential equation and your bank account balance is decreasing. So when I type that into the calculator, I get 1,500 times 0.8 to the, was it 3? Oh, 2. 2. $960 will be in your bank account after 2 years. Similar to the one before where we have to take the log of both sides, we're gonna have to do that here, and we know the output this time, so we're gonna change this for y. You wanna know how long is it gonna take, t, for you to get to $10, your y. So you'll still use 1,500 times 0.8 to the t. Put a t because we're solving for it. So I'm gonna divide by 1,500 on both sides. So when I divide, I'm just going to take that percentage. So 10 divided by 1,500, or take that decimal, 0.0067. Let's go with that. 0.0067 equals 0.8 to the t. That's going to make, this decimal is going to make it easy to take the log of both sides because we can't base change here. So it's a log of 0.0067 equals, and when we take the log of this side, that t comes down, so log of, or t log of 0.8. Go ahead and divide by log of 0.8. So if we plug that in, we have log of 0.0067, close the parenthesis, divided by log of 0.8, and you get 20. Did we do it wrong? Uh-oh. 1500 times 0.8. So I'm not going to take 20. Oh, because it's going to decrease a little bit each time once we go on in years. So this is saying it's going to take 22.4 years. So 22.4 years. Right? If we're taking the percentage of 1500, that number's a lot bigger. If we're taking the percentage of 960, that number's a little bit smaller. And every time we're getting a little bit smaller. So that's why as we go on in years, it's going to decrease a little bit at a time instead of a lot, right? Because this graph, if we were looking at this, it started up here and it decreased rapidly, and then it just decreased a little bit, right? This is TK. Okay. So that should be enough to get you through these 2, 3, 4, 5, 6, 7 problems. Make sure you upload this to Google Classroom by the end of the period. If you're SBAC testing, you have until Sunday evening. Bye.